Is it possible that Earth is actually an experimental base, perhaps? Extraterrestrial civilizations have long regarded us as test subjects and observe our every move. The question is, we have never received a response from alien civilizations. Is this merely a coincidence, or is there another reason their choice to remain silent? Is it because we haven't yet reached a certain checkpoint? To be honest, there are far too many questions about alien civilizations, but to truly uncover the truth behind them, I'm afraid we need to re-examine the entire universe's rules. So in the time that follows, I will take you deep into exploring all of this to see how these hidden truths change our understanding of the universe. Whenever the existence of alien civilizations is mentioned, I guess everyone thinks of a classic scene. That is in 1950, when nuclear physicist Enrico Fermi was having lunch with colleagues. He suddenly raised a thought-provoking question. If alien civilizations really exist, then where are they all? This question ultimately sparked the most perplexing paradox in the cosmos, the Fermi paradox. Despite the extremely high probability of alien civilizations existing, we still haven't found any clear evidence. One possible explanation is the zoo hypothesis. It suggests that alien societies already exist and clearly know who we are and where, but they choose to deliberately conceal themselves as if we are observed animals. And they are like invisible observers in the cosmos, silently watching our every move from behind the scenes. But the intentions of these alien civilizations might be far darker than that. If you're a fan of Star Trek, you might remember the prime directive of the Federation. Starfleet officers should not make contact with species not advanced enough to avoid interfering with their development, even at the risk of sacrificing their own lives. Although this is just a fictional story, this rule perfectly illustrates the core of the zoo hypothesis. Life forms from another part of the cosmos perhaps view our planet as a cosmic zoo with a one-way fence. They can see us brushing our teeth in the morning or walking the dog, but we cannot see them. In this theory, alien life deliberately keeps its distance from us, following a non-interference policy, maintaining a barrier with our planet. As if hyper-intelligent civilizations have reached a consensus, we should have the freedom to shape our own future, develop at our own pace, without external interference. Perhaps these super-advanced civilizations are 500 million years ahead of us. This also explains why we haven't found any trace of them so far. Maybe that's for the better, because humanity might ultimately be destroyed by this new cosmic force, or even assimilated like the aliens in Independence Day. Although activities like visiting an art museum might be interesting for us, for aliens this might not be very appealing. After all, the way they view everything about us might not carry the kind of interest and curiosity we imagine. Interstellar civilizations might prefer quietly observing how we develop new technologies like hypermodern satellites. According to the zoo hypothesis, alien civilizations will only initiate contact with us after we reach a certain level of development. So improving our technology and intelligence is perhaps the only way to prove to them that we are mature enough, no longer needing their babysitting. However, there are several reasons that make it hard to fully believe the zoo hypothesis. Alien civilizations might not contact us because we aren't advanced enough, but this doesn't explain why they completely ignore us. All communication attempts, even if zookeepers, try not to interfere with animals' lives. I'd bet they wouldn't ignore a bear clearly, fluently expressing a desire to communicate in language, and turn a blind eye. This is also why humans have tried again and again to establish contact with inhabitants of other planets via radio signals, yet never received a response. In 2017, about 8 miles southeast of Tromsø, Norway, a radar antenna transmitted carefully orchestrated electronic music to potential interstellar listeners. The target was GJ-273, also known as Leighton's star. This star, located about 12 light-years from our solar system, is a small red dwarf because radio waves travel at light speed. We'll have to wait over 20 years to expect a reply, but radio waves have a major problem. We don't know where to look for civilizations. They might be 17,000 light-years away, and we can't be sure what frequency aliens use for communication. On Earth, we send signals into space via radio waves. Assuming this method works for us, it might also be common for other civilizations, but in reality, for alien life, this might be an outdated technology. This is also why some research projects have begun looking for other technosignatures, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is studying the atmospheres of planets around nearby stars. Advanced civilizations might alter atmospheric composition, making it detectable by us despite decades of observation. We still have no solid evidence of advanced alien civilizations existing, but this doesn't mean they don't exist. Even if we expand our search, the probability of finding an advanced civilization remains extremely small, about 1 in 3 billion. Perhaps life in the universe is responding to our signals, but we cannot understand their method. The universe has existed for over 13 billion years, while humans have only been on Earth for 200,000 years. Just 0.01% of the universe's age, as if we're still learning to speak, even though other hyper-intelligent beings might be transmitting messages in ways we cannot comprehend at all. We are still waiting for a giant flying saucer to land and green aliens to step out. We overlook the possibility that our interstellar neighbors might be more interested in using nanotechnology to monitor us. They might be trying to communicate with neutrinos, particles with extremely tiny mass that can easily penetrate our planet without being detected by our current technology. Here the zoo hypothesis faces another difficulty. It's hard to believe so many civilizations in the universe all decided not to contact humanity. For this to happen, there must be a highly structured presence in the universe, a higher intelligence civilization acting as the cosmic leader, issuing orders and setting rules for other civilizations to keep us isolated from them. But we are discussing, after all, the possibility of billions of life forms. More civilizations also means more opportunities to violate this no-contact rule. Therefore, it's likely at least one planet, like us, is eager to find life in the universe Some scientists believe if advanced life had already colonized Earth and other planets on a large scale, we would have noticed by now. The zoo hypothesis has two more unsettling variants. In the laboratory hypothesis, no one contacts us because humanity is actually part of an experiment. Earth is essentially a giant scientific lab. Beings from other planets might be observing us, analyzing our reactions to survival challenges like tsunamis, major earthquakes. In this scenario, the non-contact agreement among alien civilizations makes even more sense. For them, it's for the greater good of scientific research, at least from their perspective. Another hypothesis, the planetarium hypothesis proposed in 2001, suggests we actually live in an artificial universe, a sort of virtual reality, creating the illusion of an empty cosmos, which isn't actually the case. However, there currently isn't any possible tool to verify this hypothesis, besides the zoo, laboratory, and planetarium hypotheses. There's another theory that could explain the Fermi paradox. Some think no one contacts us because humanity is completely alone in the universe. This is the rare Earth hypothesis. It emphasizes Earth is in an extremely unique position. No other planet has the conditions to nurture life more complex than bacteria. We might consider ourselves lucky, because any small change in Earth's orbital parameters, like Earth-Sun distance or Earth's rotation rate, would make conditions extreme, unsuitable for humans or any life. But again, contemplating whether we are alone, especially in such a vast universe, is truly very difficult. We return to the paradox. Where is everyone? Are we truly alone floating in the cosmos? This question has haunted us for centuries. Thus, scientists try to propose various theories, explaining why we haven't made contact with other life forms. One of the strangest theories is the dark force theory. It explains why we haven't contacted alien civilizations. Let's start with a relatively small scope, like our Milky Way galaxy, to better understand this theory. Our cosmic neighborhood is an interstellar wonderland, sprinkled with 200 billion twinkling stars, possibly also hosting about 100 billion planets. Assuming a small fraction of these harbor life among these distant life-bearing planets, perhaps some have evolved intelligent beings. Based on this assumption, you might think we should have encountered some strange neighbors long ago. Some might be actively searching for us or just waiting to be discovered. Now let's add a scientific flavor to this sci-fi scenario. We have something called the Drake equation. It's a universal calculation tool used to estimate how many intelligent civilizations might exist in our galaxy. You can think of it as a super-intelligent cosmic roadmap. Just tweak a few key variables. This equation will tell you, in the galactic backyard, there might be at least 20 civilizations. So the question is, since they should be around here, why haven't we seen a single one? This equation isn't simple. It considers many variables, like how many habitable planets per star system, what's the star formation rate, how much life eventually evolves into intelligent beings. Unfortunately, astronomers still can't accurately give specific values for these variables. What we plug in are rough estimates, but even so, with these assumptions, we can still draw a general conclusion. There should be dozens of civilizations in the galaxy. But the problem is, our radio telescopes have been listening, yet the cosmos remains silent. This silence is the core of the Fermi paradox, named after the man who at lunch asked, "Where is everybody?" Enrico Fermi. From that moment, humanity entered a chain of conjectures. Some say it's because life itself is extremely rare. Others say the hard part isn't life emerging, but evolving from bacteria to high-intelligence civilizations. Some think civilizations always self-destruct before maturing, like nuclear war, climate collapse, technological runaway. But one theory is more sinister than these. It's the dark forest theory. According to this theory, the universe is like a giant forest, lurking with unseen hunters everywhere. Each civilization is a creature in the forest. It must stay quiet, because you never know. If something in the darkness is watching you, why are they silent? Because it's uncertain if you are friend or foe. If you might pose a threat, the safest approach is to strike first. Eliminate you to ensure self-survival. This is the cosmic version of the survival game. Under this setting, establishing contact with alien civilizations is actually the most dangerous behavior, because you expose yourself like lighting a lamp, telling hunters, "I'm here." Thus every civilization learns to shut up, learns to hide. The universe falls into a suppressed hush state. No one dares make a sound. Everyone waits for others to speak first. Everyone fears being the next erased target. Sounds like sci-fi. Exactly. The first detailed elaboration of this theory was actually in a novel, Liu Cixin's The Three-Body Problem, But this idea was actually proposed earlier by scientist David Brin. He suggested the reason we haven't heard alien radio signals might be because broadcasting them carries the risk of being eliminated. He even speculated perhaps the hunters aren't organic beings, but some kind of automated machine civilization executing a program to eliminate potential threats across the cosmos. Sounds crazy, but the scary part is this theory doesn't require assuming all civilizations act this way. As long as there is one sufficiently powerful hunter civilization, other civilizations will choose silence out of fear. This might explain why, after listening for over a century, we haven't received any advanced signals. It's not that no one is broadcasting, but that no one dares to broadcast. But this theory also has loopholes. It's based on the premise that alien civilizations' thought processes, risk aversion, value judgments are the same as humans, or perhaps there really is a rogue civilization actively hunting all neighbors it deems dangerous. This assumption is not small. If you think this is creepy enough, then the next part might truly send shivers down your spine. For about a century, we have been shouting our existence into the cosmos. If this theory is correct, then civilizations within 100 light years of us might have already received our signals, know exactly where we are. If we have reason to hide, as Stephen Hawking suggested, then we might already be in trouble. But what if this theory isn't true? What if bizarre galactic beings earlier than we imagine are actually trying to contact us? In fact, most people don't even know what to do. Don't be too arrogant, actually. Some scientists have long faced this issue. Since the 1980s, experts have tried to draft a guide telling us how to respond if contact with cosmic neighbors occurs. For example, Some researchers think we shouldn't just worry about how these life forms might disrupt our world if they send any radio signals. We also need to consider how to respond. What should we say? Hey, we're humans. Nice to meet you. Absolutely not. We have to do better than that. Until now, our only plan comes from a rough blueprint in 1989. It gives some vague suggestions on what to do if the whole world receives an alien message. Most of it just says, hey, we have to tell everyone the news. Then what if we confirm the message is real? Certain bodies need to inform the United Nations. But does the UN really have a plan? Who knows? We have indeed conducted a lot of space exploration recently. Some say we found water on Mars. Others are convinced we found planets possibly similar to Earth. So the idea of finding life elsewhere isn't too far-fetched. But even after 100 years of effort to communicate with cosmic life, we are still broadcasting unilaterally. This new protocol isn't just about chatting with aliens. It will also serve as our cosmic voicemail, checking for messages from outer space. It's not just decoding alien language. It also plans to figure out what these messages mean for us. This plan also includes writing reports, analyzing impacts of different policies, and developing guidelines on how to respond to these space messages. So will we really receive a message from cosmic friends? Only time will tell, but what we know is we must not be unprepared. Can't wait until an alien message arrives for global panic to start. We need a plan and be ready to face a true alien civilization. I mean, although we have had many potential sightings, none turned out to be real. U.S. authorities examined over 100 cases of anomalous aerial phenomena. I won't go into details, but not a single green being was found. They were more like drones or something similar floating around. So standing at this moment that could change everything, we must be prepared. Whether our interstellar neighbors text us tomorrow or centuries later, we need a plan. After all, this could change all our understanding of the universe and our place in it. According to the panspermia theory, life might have been delivered to Earth via meteorites, comets, or asteroids from different spatial regions. Although this theory remains purely hypothetical for now, we can analyze whether it might be possible. Traditionally, astrobiologists focused on searching for extraterrestrial life have been exploring the possibility of life in the subsurface oceans of Mars, Saturn, and Jupiter's icy moons. But actually, simple life forms might be more widespread. They might now be floating in interplanetary space as dormant bacteria and spores. Several scientists pointed out the extreme environment of space might severely damage these spores and microbial DNA and RNA. However, other scientists think enough microbes might be floating in dust clouds, and some microbes might survive in primitive forms. The panspermia theory has several different versions. For example, lithopanspermia suggests microbial life of some kind might be blasted into space during planet-comet or planet-asteroid collisions, becoming cosmic debris, eventually arriving on Earth. Whereas radiopanspermia proposes life might rely on radiation from stars to travel through space. But the problem is, How can ultraviolet and X-ray radiation combined with the vacuum of space not completely destroy microbial life? There's also a view called pseudopanspermia. According to this theory, organic building blocks of life might form in interstellar dust clouds, then be transported to planetary surfaces, where life begins to develop. It does sound very interesting, but is there any evidence supporting the panspermia theory? Actually, some orbital experiments have been conducted. From 2008 to 2016, special equipment exposed for sample collection, primarily studying astrobiology. These devices were installed outside the International Space Station, specifically exposed to space conditions. Later, these samples were brought back to Earth for analysis. Results showed some of these samples successfully survived these extreme environments. One experiment even showed 100% of bacterial spores survived under simulated Mars conditions. Even more surprisingly, some seeds survived in space and grew into plants after returning to Earth. The U.S. Long Duration Exposure Facility satellite and Russia's Biorak experiments on the Photon capsule also showed that spores, seeds, even tiny animals like tardigrades could survive in space for years. In the 1969 Apollo 12 mission, a piece of the Surveyor 3 lunar lander was brought back to Earth. Astonishingly, it still had an Earth bacterium on it. This bacterium, without protection on the airless lunar surface, actually survived for over 2 years. Of course, it's also possible this bacterium was brought back via lab contamination. Meanwhile, the Indian Space Research Organization also conducted space microbe searches using balloons to sample the stratosphere. Results indicated planetary cells of life were found in air samples from above 25 miles. Normally, lower atmosphere air cannot be transported that high, so this discovery seems to further support the panspermia theory. But in 2010, during NASA atmospheric sampling before and after hurricanes, it was found that under certain conditions, Earth bacteria could indeed be lifted to very high atmospheric layers. However, the main argument against panspermia is, if this theory is true, then life found throughout the solar system should share a common origin and share major biochemical features, like the genetic code. But this seems somewhat unbelievable. In fact, many experts believe only astronauts landing on planetary surfaces like Mars, Europa, or Enceladus can truly resolve the question of life in the solar system. This way, astronauts can compare any life forms found with Earth-type life. This might be the ultimate test for panspermia theory. However, until probes find direct evidence of space life, this theory remains unproven. If we turn to the multiverse theory, things become even more complex. If this theory holds, then we are not the only universe in existence. This idea is both exciting and unsettling. Of course, not all scientists accept this dizzying concept. To be honest, the idea of contact with parallel universes sounds as unlikely as winning the lottery while riding a unicycle, but it's noteworthy this concept is no longer confined to science fiction. Some scientific theories actually support the existence of parallel universes. This has sparked intense debate in the scientific community. Imagine the universe we live in is staggeringly vast. Scientists speculate our universe contains billions, even trillions of spinning galaxies, each galaxy filled with countless stars. Some researchers propose the universe's diameter might reach a staggering 70 billion light-years. Some even think the universe might be infinite, so could there be other things we haven't discovered? Some scientific theories in reality are exploring that the universe might be more than what we see, even coexisting, interweaving with our universe, or beyond it. These interesting concepts of multiverse and parallel worlds often intertwine with more familiar scientific ideas like the Big Bang Theory, string theory, and quantum mechanics. To understand the world out there, we need to rely on some theories we are more certain about, right? Let's go back to that moment 13.7 billion years ago. According to the Big Bang Theory, everything we see today was compressed into a tiny singularity. If the Big Bang Theory is correct, then everything exploded in that instant. The universe expanded faster than light. In less than a second, expanded to today's scale. The way the universe expanded made some clever researchers question whether multiple universes exist. They wondered whether this sudden, violent inflation process ended everywhere simultaneously. Although we know cosmic inflation stopped 13.8 billion years ago, and the universe we see from Earth has reached its current scale, in some mysterious corners, inflation might still be continuing. Some theoretical physicists propose when inflation ends in one region, a new bubble universe forms. The problem is you can't just jump from one bubble to another like an interstellar tourist. These bubble universes are infinitely expanding. Their edges far exceed light speed and are rapidly moving away from us. This becomes even more puzzling. Suppose we managed to reach the edge of our local bubble, encountered the next universe. These same theoretical physicists also mention adjacent universes might be completely different. They might have entirely different physical laws. For us, that would be an extremely strange place. Following this line of thought, some think, in this vast multiverse of bubble universes, there might also be beings like us. The problem is, we are moving farther away from them. Our paths will never intersect. Moreover, some very clever researchers are trying to link parallel universes with quantum mechanics. Quantum mechanics is essentially complex mathematical models describing extremely small particles. According to its theory, these particles can exist in multiple states simultaneously. They are called wave functions, containing all crazy possibilities. But here's a catch. When we observe these particles, we only see one outcome. It's like the universe playing hide-and-seek with us. Now there's a theory called the many worlds interpretation. It says whenever we observe one outcome, another universe pops up where a different outcome becomes reality. It's like our universe is a giant tree, continuously branching into countless versions. These parallel universes cannot intersect, so you wouldn't even know if another you exists, living a slightly or completely different life. This many worlds interpretation is very bold and hard to prove or disprove. For science, this isn't easy because scientists like to test ideas through experiments. However, if the universe is truly infinite, why couldn't there be infinitely many universes? Try to imagine the universe is like a giant cosmic playground. Some experts think if the universe is truly endless, then its constituent elements have only a finite number of arrangement patterns. Eventually, they must repeat certain patterns. If this is true, then perhaps somewhere there might be another version of you living exactly the same life, even eating exactly the same lunch as you did yesterday. So do we have any evidence to prove the existence of these parallel universes? Some say we do. Have you heard that mysterious story of the Tord man? That's a man who appeared at a Japanese airport, claiming he came from a completely unknown country called Tord. Some think it's evidence of time travel, while others think it's evidence he came from another parallel universe. Although you might want to believe this story is true, the problem is this place Tord. Why have you never heard of it? Because there is no such place as Tord. Not today, nor in the 1950s, when this incident supposedly happened. That man mysteriously disappeared the day after arriving in Japan. Let's go back to that day in July 1954, when the man claiming to be from Tord reportedly landed in Tokyo. Described as a bearded man speaking French. So far, things don't seem too bizarre, right? But depending on the version of the story, things start to differ. In one version, when the man presented his passport for stamping, the Japanese official's eyes widened. Although the passport looked legitimate, it said Tord, a country no one had heard of. Even the officials and other staff were puzzled, so they decided to take our Tord visitor for questioning. In another version, the man directly told the inspector he was from Tord and showed his passport, but the inspector obviously didn't believe him. The man from Tord tried to convince the inspectors, telling them his homeland really existed. According to him, Tord was located between France and Spain and had existed for about 1,000 years. To prove his point, he even pointed to a spot on the map corresponding to the Principality of Andorra. Obviously, things got more mysterious. They decided to detain him, suspicious he might have malicious intent. So they placed him in a nearby hotel overnight, but didn't relax vigilance, even posted two guards outside his room. What happened next you might not guess. The next day, when officials came to his room to continue investigation, the man was gone. Even more puzzling, there were no signs of escape. Stranger still, all his personal documents also vanished mysteriously. What if the Tord man was really a time traveler or an interstellar adventurer? Some even entered sci-fi territory, trying to find an explanation for this bizarre event. You might not believe it, but many on the internet take it as evidence of parallel realities. One of the weirdest ideas is this man might have accidentally slipped into a parallel dimension, ending up at this Japanese airport. In that parallel universe, there is an Earth just like ours, except they call it Tord. Another view is the man was a time traveler from the future. Sorry to burst your bubble, but the most reasonable explanation is this story might just be someone's overly active imagination. Because there are too many versions of the same story, people might have kept adding exaggerated details, making it more sensational. The whole story eventually became an urban legend with little reason to believe we've ever encountered time travelers or interstellar travelers on Earth. In 1994, something strange happened. As dusk fell, no one saw two figures open the emergency exit of Biosphere 2, the glass dome building in Arizona. They were determined to rescue 7 people trapped inside for a month, risking their lives to complete the task. Although the mission succeeded, they were charged with illegal trespass and property damage. These trespassers were Abigail Ailing and Mark Van Thillo. They were among the original 8 crew members who moved into this place as experimental guinea pigs. They didn't want others to experience the horrors they endured. With funding of $150 million, this experiment aimed to see if humans could create livable conditions on other planets, like Mars. To achieve this, scientists built a mini-world with over 3,000 species of plants and animals. Biosphere 2 was a sealed 3-acre ecosystem with its own mini rainforest, private beach, coral reef, grassland, wetland, even a desert. During 1991 to 1993, nothing could enter or leave this place. The 8 trapped people called themselves Biospherians, wearing identical Star Trek-like flight suits, growing their own food, breathing their own air. They were initially hopeful, eating 5-star hotel-style breakfasts. But after a few months, the situation took a dark turn. The whole team was starving. Their skin turned orange. In Biosphere 1, which is our real Earth, you can order a pizza in 2 minutes. However, in Biosphere 2, it took them for months to barely make a margarita pizza. They had to harvest wheat for dough, milk goats for cheese. Their goal was complete self-sufficiency, to become an independent ecosystem, and they indeed became part of an atmosphere. When they breathed, the carbon dioxide they exhaled fed the sweet potatoes they grew, and these sweet potatoes became part of them. Because they were essentially eating the same carbon, the result was they ate so many sweet potatoes, their skin actually turned orange, all due to excess carotene. It might seem funny now, but it highlighted a big problem. Biosphere 2's crop yields were disappointing. Team members began starving. They became crazed by hunger. Sudden fits of rage made them do many things they regretted, like stealing bananas. They even had to lock the refrigerator. In the first 6 months, each person lost an average of 18 to 58 pounds. One person daily weighed fresh food, allocated it to the cook, and entered nutritional info into a computer to ensure the team met recommended calorie, protein, and fat intake. Initially, food was buffet style, but as hunger grew stronger, the cook began meticulously portioning each meal. Their diet was mainly sweet potatoes, carrots, fruit, and occasional Sunday meat, which was supposed to sustain them through those tough 80-hour work weeks. But the Biospherians still felt hungry after each meal, and they often dreamed of McDonald's burgers, sushi, Snickers, and cheesecake. The air was running out. The entire place was completely sealed with steel and glass. Steel on top, a solid steel floor at the bottom. Managers ensured checking every item that entered, avoiding synthetic materials releasing harmful gases. In the living quarters were wooden and wool furniture. No chemical deodorants, or blowing out birthday candles allowed the biospherians relied on the food they grew and lots of rainforest to produce enough oxygen to keep them alive. However, their oxygen was consumed very quickly, almost drowning in their own CO2 emissions. Worst of all, they didn't know why. With 9 months left in the experiment, oxygen levels dropped from 21% to about 15%. It was like living atop Mount Fuji. They felt terrible, basically dragging themselves around biosphere, stopping to catch breath, even to speak. Then sleep apnea began. Some woke up at night gasping for air, trying to lower CO2 levels inside biosphere 2. They tried desperate measures like frantically planting more plants, minimizing watering, even abandoning tilling soil, but nothing worked, so the group decided they had reached a dangerous point. To ask for outside help, refrigerated trucks appeared, started pumping pure oxygen into biosphere 2. As oxygen flowed in, they couldn't help but laugh and started running around inside. The ecosystem completely collapsed. Hummingbirds and bees disappeared after a few months. Plants were no longer pollinated. Worms and broad mites attacked. Crops, cockroaches took over the place, for cockroach species were introduced to recycle organic matter. But common household cockroaches became the ultimate survivors. They managed to sneak in and multiply, becoming a serious threat to crops. At night when lights went out, the kitchen was overrun with cockroaches. To combat these bugs, the team coated coffee cups with grease, then put papaya inside as bait. Cockroaches would crawl in, but couldn't climb the greasy walls to escape starvation. Oxygen deprivation, insect infestations were enough to drive anyone crazy. Heated arguments led to flying cups, even people spitting at each other. Eventually, the whole team split into 2 factions. They stopped talking, wouldn't even look at each other passing in hallways. One faction wanted more food and oxygen to continue research with some dignity. The other insisted they could survive without outside help, no matter the cost. In fact, the seal had been breached early, just 2 weeks in. A biospherian named Jane Pointer accidentally cut off her fingertip while cooking. The mission doctor tried to stitch it, but failed. Within days, her finger turned black. She had to go outside to a hospital for surgery. A few hours later, she sneaked back into biosphere with a bag of supplies containing computer parts and color film. Months later, journalists learned of this covert delivery. Thus, many questioned the experiment's credibility. Media covered the experiment like a reality show, calling it trendy eco-entertainment. Headlines worldwide made it seem they were almost dying, so much that family members grew worried, calling to ask if the biospherians were really okay. The team felt like they were in a human zoo. Tourists came from afar, staring at them through glass cages. In just the first 6 months, over 150,000 people visited the place. Biosphere 2 ultimately became a pop culture punchline, inspiring the movie Biodome and decades of comedy sketches. You might ask, why didn't they quit the experiment? Walk out the door. Actually, no environmentalist wanted to be the first to admit they couldn't handle it, and they still held hope that they could crack the puzzle of building a second Earth. Finally, they managed to find the 7 tons of missing oxygen. It had been absorbed by the concrete, although constant oxygen deprivation seemed their biggest challenge. The biospherans said learning to handle interpersonal relations in a closed environment was even harder. It seems the experiment was a huge failure, but the team did learn valuable lessons. They proved that a closed ecosystem could function. For years, they contributed to coral reef restoration research. Their farm demonstrated high yields and complete nutrient cycling could be achieved without toxic chemicals. If you're wondering, biosphere didn't end there. A second biosphere experiment began in March 1994. Now you can go back to the video's beginning to see how that experiment turned out. Perhaps there is another universe, like a dark mirror of our own, where time flows backwards. This inverted world might also be the source of dark matter, that invisible stuff permeating our universe. Perhaps in another universe, there's another you who woke up this morning, but chose to wear a white t-shirt instead of red. That would set him on a completely different life path. But let's start with this mysterious dark matter. It constitutes most of the universe's mass, yet we aren't sure what it does or where it comes from. Because it doesn't behave like ordinary matter, we can't see it, can't feel it. We only know it exists because it seems to bend gravity. Although ordinary matter and dark matter are very different, they seem to coexist in some balance. Some scientists think there must be some connection between the two. A new theory proposes for every ordinary matter particle's motion, there is a mirrored version in the dark matter world, like a bridge connecting the two worlds. In ordinary matter, there's also a strange coincidence. The masses of leptons and protons are almost identical, allowing them to combine, form stable atoms, letting us see all matter. If protons were slightly heavier, the balance would break. Atoms couldn't form. In the dark matter mirror universe, perhaps things are different. Maybe there, the proton's equivalent cannot combine with other particles, leaving lonely neutrons. This might be the source of dark matter. This theory also suggests dark matter might have its own chemical structure, like dark atoms forming a dark periodic table. For a long time, scientists thought dark matter was only one type. Although these particles are similar in some ways, like being nearly invisible, they might differ in size, speed, and how they affect ordinary matter. If this theory is correct, it means there might have been some interaction between our universe and the dark matter mirror universe. Studying element formation in the early universe might give us some clues. The idea of a flipped world has sparked great curiosity in recent years, even some confusion. Astronomers use a theory called the lambda CDM model to explain our universe's composition and behavior. According to this model, the universe is mostly made of two things: dark energy and dark matter. Dark energy is like the force pushing the universe's accelerated expansion, while dark matter uses its gravity to pull things together like cosmic glue. Ordinary objects like stars, planets, and comets are only a tiny part. This model also tells us about the Big Bang process and how everything started from a hot, dense singularity. The universe has been expanding and changing since then. Although this model seems correct in many ways, It doesn't explain all cosmic phenomena. If you draw this model on paper, it looks like flat pancakes stacked. Each pancake represents the universe's state at a certain time. Yesterday's universe would be below today's, but it would be a slightly smaller pancake. Eventually you see the universe's history looks like a giant inverted cone. The smallest tip is the Big Bang. Beyond this point, we can't look further back in time with current tools, so we don't know what's beyond. More importantly, we still aren't sure what exactly happened after the Big Bang, but if we just apply mathematics, the universe might extend beyond this historical turning point, meaning it might extend backwards, creating a similar mirror inverted cone. From our perspective, time would flow backwards. This alternative idea not only challenges our understanding of cosmic origins, but raises questions about fundamental physics principles. All the excitement about a mirror universe also stems from findings by scientific instruments stationed in Antarctica. The Antarctic Impulsive Transient Antenna ANITA detected strange high-energy particles seemingly bursting up from below the Antarctic ice. The problem is, these particles don't behave as physical laws predict. Scientists think they are a type of cosmic ray. They travel from space through Earth and come out again. But known particles shouldn't behave this way because higher energy particles usually collide with something inside Earth, not traverse to the other side like these particles. They seem to do something forward and backward. So far, there's no solid evidence for a mirror universe. These particles might just be a new type we haven't discovered. Scientists need to study them more carefully, find out why they behave this way. It's like a 4-year-old's behavior. But what if not just one parallel universe, but more? This multiverse concept comes from ideas like inflation theory. Inflation theory suggests our universe underwent a violent expansion early on. Although inflation stopped in our patch of the universe billions of years ago in other regions of the multiverse, it might still be continuing, creating different universes with their own physical laws and unique features. Our universe is the only one known capable of supporting life. For example, we have stable stars, providing heat and warmth crucial for organisms' movement. We also have abundant elements like carbon and hydrogen, essential for our existence. The multiverse hypothesis offers an explanation for why our universe exhibits conditions so suitable for life. It might explain why in countless other universes life's existence becomes unlikely. A fascinating implication of the multiverse theory is the concept of doppelgangers, individuals in these parallel universes that are exact copies of us. This concept suggests in the vast expanse of the multiverse, there might be countless scenarios where our duplicate versions are experiencing similar events. Before we start crossing into other universes, we might need to understand our own universe better. For example, there is a distant galaxy that might have no dark matter at all. It's about 250 million light-years away. At first glance seems normal, but if we look closely, we seem to find no dark matter. If more galaxies like this are eventually found, it might change our understanding of galaxy formation. Usually, dark matter is considered essential to this process. It's like the glue holding everything together. However, indeed, this particular galaxy's brightness is fainter than usual galaxies, has fewer stars than usual. When first discovered in 2019, scientists thought it might lack dark matter. The reason was it rotated too fast. A galaxy's rotation speed tells us how much mass it has by comparing this speed with the visible matter we can see. Astronomers can calculate how much dark matter it must have, and in this unique galaxy, the math indicated it had none. Among all these theories, there's also one suggesting dark matter isn't real at all. New research proposes maybe we've been searching for something that doesn't exist. They think our understanding of gravity might not be good enough to explain why some galaxies behave oddly. Thus they think dark matter isn't the cause of these strange phenomena. Perhaps we simply don't understand how ordinary matter works. They base this on a theory called modified Newtonian dynamics (MOND). This theory suggests at very large distances or very low speeds, gravity behaves differently. A Dyson sphere is a theoretical mega-engineering project, a giant sphere encircling a star, platforms densely packed orbiting the star. It's supposed to be the ultimate solution for energy production and living space. The creators of a Dyson sphere would gain vast surface area for habitation and be able to capture every tiny bit of solar radiation and heat from the star. The first to theorize such a bizarre structure was British-American theoretical physicist Freeman Dyson. According to him, an intelligent alien civilization might consider building such a sphere after colonizing local systems, moons, and planets. As their population grows, these aliens would need more and more energy to sustain life. Dyson calculated if this alien society grew at 1% per year, the area and energy needs would increase 1 trillion-fold in just 3,000 years. If their solar system had a Jupiter-sized object, they could disassemble it and distribute its mass in a spherical shell at a distance twice that of Earth's sun. This much material would be enough to build numerous orbital platforms. Each platform could be 6 to 10 feet thick. This essentially would let this civilization live on the star-facing surface of these platforms. Such a shell thickness would be very habitable and could house all devices using solar radiation without the shell falling into the star from inside. But after absorbing all this solar energy, the sphere must re-radiate it. Otherwise, energy would accumulate, eventually melting the structure. This means a Dyson sphere enveloping a star would appear dim or even completely dark, depending on how dense the orbital platforms around the star are. Meanwhile, it would be anomalously bright in infrared wavelengths, invisible to the naked eye. Thus, Dyson spheres are classified as a technosignature, a sign of activity. Astronomers could use it to discover if intelligent life exists in the cosmos. On Earth, some researchers already have infrared maps of the night sky. They are studying these maps, hoping to find Dyson spheres. So far, no one has found one, but one study singled out several Dyson sphere candidates. Researchers used a special data processing pipeline, combining and analyzing vast information. One main search criterion was detecting excess infrared radiation simultaneously. It's also crucial to distinguish this radiation from that emitted by natural objects. After complex filtering of millions of objects, researchers identified 7 potential Dyson spheres, although further analysis is necessary to determine their nature. For this, scientists plan to use optical spectroscopy. This might reveal more details about these objects and their origins. Meanwhile, researchers also acknowledge these Dyson sphere candidates might have other explanations. For example, they might be young stars' debris disks or protoplanetary disks. Only more research will show whether we can find traces of other civilizations in the galaxy. So far, this remains an open question. Interestingly, Dyson spheres are widely discussed in science fiction. As early as 1937, Olaf Stapledon's novel Star Maker described systems in a particular galaxy surrounded by light traps that concentrated solar energy for intelligent beings. Because of this, the entire galaxy's brightness dimmed. In another novel, Ringworld *, the author mentioned an artificial ring structure around a star. This is the James Webb Space Telescope. This is what it can see through its eyes. Very impressive. But let's zoom out a bit more. Zoom out a bit more. Zoom out a bit more. The image becomes increasingly blurry. Wait, what's this? A shadow. This is a giant telescope, capable of seeing perfect detail in those seemingly blurry images. NASA's Roman telescope will launch in 2027. It might help us unravel cosmic mysteries, including the nature of dark matter. Rest assured, James Webb will continue showing us the universe's beauty and solving puzzles one by one. But today astronomers have a new mission. They hope to deploy the next larger space telescope. This mission is already well underway. The Nancy Grace Roman Space Telescope will likely open a new era in astronomy. Scientists hope this telescope will collect more data than all previous NASA missions combined. Hubble and Webb space telescopes have excelled at zooming in and getting clear, detailed images, while the Roman telescope will give us a much wider field of view. It will be able to capture infrared images 200 times larger than Hubble's. At the same time, it will also have the same high level of detail. But even if the new telescope provides perfect images, it's primarily intended for large-scale surveys. Suppose we need to search for star populations in a nearby galaxy, but that's too large a field for Hubble. Using Hubble, we'd have to mosaic multiple different images into one large picture, but with Roman, just one shot can get a full panorama of the entire galaxy. Look at this recent mosaic of the nearby Andromeda galaxy. This image was stitched from for 100 separate Hubble shots, while Roman would paint the same ultra-wide image with just 2 images and the same level of detail. This not only sounds cool, it also means unprecedented data volume. Once we have a panoramic view of the universe, NASA and other space agencies might finally answer some big questions that have long puzzled humanity. One primary goal is to test Einstein's theory of relativity. This theory has been well verified on our solar system's scale, but not thoroughly tested on larger cosmic scales. According to this theory, Visible matter should slow the universe's expansion. However, the universe keeps expanding and expanding faster and faster. Thus, astronomers attribute this increasing expansion rate to a mysterious component, dark energy. They think dark energy makes up about 68% of the universe. Hopefully, the Roman telescope will provide data, helping us accurately measure positions and distances to millions of galaxies. Ultimately, it might let us figure out how fast the universe expands in different regions. The final result might tell us whether Einstein's gravity theory needs modification. Another major goal of the Roman telescope is detecting hundreds of new exoplanets within our galaxy. The telescope will use a technique called gravitational microlensing. You see, when two stars align, the foreground star distorts and magnifies the background star's light. If the foreground star has planets, we can see how this planet affects the background star's light. Roman will hope to calculate for billions of stars, giving us very good statistics on how many of these stars have exoplanets. This cutting-edge telescope will not only find new exoplanets, it will also carry another key instrument called a coronagraph. It can image exoplanets close to their parent stars. Actually, this is an extremely complex technology because the star's light must be suppressed. After all, stars are much brighter than the objects you want to study. The coronagraph on the Roman telescope will attempt to directly capture giant planets like Jupiter, performing real-time corrections, enhancing image quality. If it works well, then this will be a great demonstration tool, paving the way for technology on future space observatories. These astronomical telescopes will be able to directly capture Earth-like planets located in stars' habitable zones. But the Roman Space Telescope isn't the only project that could change how we explore space. There are other concepts, like the Theia telescope for habitable exoplanets and intergalactic astronomy, based on a new technology idea of revolutionary space telescopes with special optics. These optics might let us overcome the main limitation of space telescopes. Non-scalable primary mirrors, Theia technology, could provide large but ultralight telescope apertures, making it possible to launch a fleet of large, identical telescopes. They would have impressive light-gathering power, helping Theia survey thousands of Earth-like planets in stellar habitable zones. Ultimately, we might find signs of life in these planets' atmospheres. All right, my friend, let's pause our conversation here tonight on the mysteries of the universe. Now, allow me to press pause for you. Set aside all thoughts and inquiries, and simply, quietly be in this moment. From here, my voice will fade away, leaving only the silent tapestry of the cosmos and a carefully chosen piece of pure music tuned to 432 Hz. Science suggests this frequency resonates deeply with the natural vibrations of the universe and the rhythm of life itself, soothing your nervous system and guiding you into deep relaxation. Now, find your most comfortable position. Gently close your eyes or let your gaze rest softly upon the stars. May you release all weariness from the world, letting your consciousness drift on the waves of music, floating into boundless tranquility. Good night, sweet dreams, until we meet again among the stars.